Hey there, physics students, and welcome back to Rapid Review for Honors Physics. Today, we're going to be talking about rounding and significant figures. You're doing a lot of problem solving. You're going to need to be thinking about rounding and how you round numbers in your calculations, and even how you round G. I'm going to talk a little bit about G as well here today. So, getting right down to it, reminder, significant figures shown here, these are all three significant figure numbers. If I said 8, that's one significant figure. 8.6, that's two significant figures. I will assume you've seen a bit of that already. You've probably learned a lot of rules about, or some rules about, doing significant figures. I'm going to simplify things into saying, I think you should just be reasonable. So you'll want to check in with your own physics teacher about this and what the requirements are for your class, but I'm going to show you here what I think is reasonable. And it's all here on this one slide. I will not read all of the words, but you just have to see what was provided, and then you have to answer in the same number of significant figures that were provided. So if you were given 6 significant figures, you would have to provide 6 in your answer. You should use everything that's provided. Don't round anything that was provided. And during your calculation, you should use extra significant figures. In the end, you round only once. This is really the big thing, right? So use lots of significant figures through your calculations and round only once at the end. In a multi-part problem, you'll see that if you use the unrounded version of your numbers throughout the problem and then only round once at the end, you'll get the best answer. Okay, so that's the rules. Now let's talk about what that looks like in real life. I did an experiment with my students once. We looked at answers to a given problem. This was a homework problem, and it's trying to figure out acceleration in a kinematics problem in one dimension. You'll see, without getting into every line item here, you'll see that what I did was list my available information and then solved and reported my answer in 3 significant figures because the problem was given in 3 significant figures. Okay? So that's how you approach the rounding for that. Because this was a multi-part problem, when I wanted to answer part B, I used the unrounded version of my acceleration. So I knew the acceleration was 0.714, which I calculated earlier, but I used the unrounded in part B to get the correct answer, which I, again, reported in 3 significant figures. So the point of this is use all the significant figures you've got, keep some extra significant figures in the process of doing your calculation, and then in the end, report back in the number of significant figures that was provided to you in the problem. Common mistake we have seen in the class is maybe too much rounding. Here's a student who solved this problem with too much rounding. This student got up to this point in problem solving and then solved for A, or is working towards solving for A, divided 316.8 by 222 and came up with, just 2 significant figures, minus 1.4. That's too much rounding. If you do that much rounding, you're going to lose information and you are at risk of getting the wrong answer. Okay, let's come back to this student. I will not address the, there's actually an extra mistake in this calculation, which is not worth worrying about. I'll let you find that if you're curious, but what's most important is that too much rounding is a problem. Likewise, not enough rounding is a problem. Here's a student that solved the same, or this is a different problem, but the question was asked giving 3 significant figures for all the data. This student answered with as much as 6 significant figures just too much. You have no right to answer in significant figures if you haven't been provided those in the problem statement. Okay, let's move on then to G. I have been using 9.81 for G. I sometimes use 9.8, and I will tell you that the difference between 9.8 and 9.81, I've done the calculation. If you use one versus the other, your error is going to be 0.1%. It's not a big deal. So I don't make a big deal out of 9.81 versus 9.8. In fact, if the problem is in 3 significant figures, I will acknowledge lazily just write 9.8, and I know what I mean. I mean 9.80, which is close enough to 9.81. Okay, check in with your teacher again on your class's requirements. Make sure you're doing things correctly for the standards that are in your class. So pragmatically, 9.8 is pretty good, and I always allowed that in my class. Now, what is G? There is an organization called NIST, the National Institute of Standards and Technology. And they claim, if you look at this, that G is, depending on how many sig figs you want, G is available from them. It's just a standard agreement. Now, that's just so that when I'm calculating, I get the same answer as my friend in California or Denver, because according to my John Coley physics textbook, gravity differs by quite a lot. If I'm in Denver, 9.796. New York, 9.803. Even in Westford. So Westford, Massachusetts, the gravity is 9.80385 if you need it to all those significant figures. Okay? How do I know this? Well, NIST has done the research and can tell me in a calculator that's provided online. I'm going to show you the link for that right now. You can stop the video and read this link. I'll also post it in my video post. But I just asked NIST what gravity was in Westford, Massachusetts, in the United States, and I got a pretty good answer. So how do they know? I don't know. It's a good question. We should ask them sometime. But for now, that's gravity in Westford. We know the standard gravity, and I think we know enough about rounding for today. So let's call it quits, and I'll see you in the next episode.